In 8.4, they want us to solve equations that have this format here. If we look at this a little bit closer, this is not our normal quadratic, so therefore we cannot do a completing of the square. We cannot solve this by using the quadratic formula because, again, our exponent has an exponent of 4. We have to have a trinomial that has an exponent of 2. So how are we going to work this out? Well, we can use the quadratic formula or completing the square on this, but we have to do a couple of things before we do that. We're going to do substitution. If I can somehow rewrite this in a form of a quadratic formula, I can work it out as if it were a quadratic formula. So I would really like this x to the fourth to be an x squared. So let's rewrite this knowing what we know about exponents. I can rewrite x to the fourth as x squared squared, or to the quantity of 2. We know that this would be x to the fourth. Same thing can be done here. With our b value, we can write this as 7 quantity x squared. Okay, we're going to do a little bit of substitution. I'm going to let a variable u equal our x. So I'm going to let it equal x squared. So I'm going to let u equal x squared. So it's going to substitute this value right here so that we can get it into our basic format. So let's say, for example, let's do that right now. That would be minus 7u minus 18 equals 0. See, already it's starting to look like a basic quadratic formula where we have our variable here in the center to the 1 power. Okay? Well, if I let u equal x squared, that would mean that u squared would have to equal x to the fourth, right? Because if I square here and I square this, then that becomes x to the fourth. So that means u squared is going to replace this x to the fourth that's right here. So I can rewrite that as u squared minus 7u minus 18 equals 0. Okay? So notice how I got it from a quadratic all the way up here at the top just by substituting u in for the x squared, squaring the u, squaring the x squared to get u squared equals the x to the fourth. I was able to substitute the original equation here using my u's to get it down to a quadratic formula. Okay, so this is our quadratic that we're going to work with, and we would go ahead and work this out the same way we do a normal quadratic equation. So I would factor this. Factors of negative 18, that's subtract out to negative 7. That's going to be u minus 9 and u plus 2. Okay. So that means that either u is going to equal 9 or a negative 2. Okay? Here's the thing is that's only our u values. I don't know what my x values are. I have to solve for x. Okay? So we need to go back to our original up here. We let u equal x squared. So let's write that up there. U equals x squared. Okay? We got two of these. U was either 9 or u was a negative 2. Okay, notice how I have a square here and a square here. That means I'm going to get 2 values here and 2 values here for a total of 4 values. So therefore that's where our 4 values come into play here, because again we have to have 4 solutions. If we have a polynomial equation with a 4th power, that means we have to have 4 answers or 4 solutions. So therefore we go back over here, we solve for x, we take the square root of both of these, so x is going to equal plus or minus 3, so that means that x is either a positive 3 or a negative 3. Okay, and then over here we got to take the square root, so that means that x is going to equal the square root of a negative 2, which is the same thing as I, or plus or minus I, square root of 2. Okay, so our values are there. plus or minus I square root of 2. So these are 2 solutions and these are 2 solutions right there for a total of 4 solutions. Looking at my board here, you're like, I thought I was done. No, we actually have to check our work, which means that I have to stick all of these values into the original equation and to make sure that when I substitute these all, I should get a true statement, which would be 0. Okay, I've done the first 2 out here. I substituted 3 in for the equation here. 3 to the 4th power is 81. 3 squared is 9. Negative 7 times a negative 9 is a negative 63. 81 minus 63 is 18. 18 minus 18 is 0, so that one checks. On the second one, I'm working with a negative 3, but because we're working with even exponents here, this 4th power and this squared here, we're going to get positive values, so it's just going to mirror image the left-hand side, and since the left-hand side was correct, then the right-hand side was correct. So the next one is to substitute those imaginary numbers in there to see if those 2 work also. Okay, here I've substituted I square root of 2 in for my equation. So right here is just the basic substitution into the equation. If I take I square root of 2 to the 4th power, that becomes I to the 4th, because remember you're taking the 4th power of the I and of the square root here. I can rewrite the square root as 2 to the 1/2 power, as we learned back in chapter 7. Over here, this again becomes I squared, and then if I square the square root of 2, that just becomes 2. I to the 4th power, we learned this on chapter 7, the end of chapter 7. I to the 4th power is a positive 1 because I squared is a negative 1. So I squared times I squared would give me I to the 4th. Squared times I squared. I squared is the negative 1, and then a negative 1 times a negative 1 would give us the positive 1 here. So this becomes 2 to the 4/2, and 2 to the 4/2 just becomes 2 to the 2nd. I squared is the same thing as the negative 1. The 2 stays constant, but if I have a negative 7 times a negative 1, that's a positive 7, times 2, which is 14, and again the 18 is just trailing all the way down here because the only thing we need to work out are the i's. So 2 to the 2nd becomes 4. This was a positive 14, and positive 14 and 4 give me 18 minus 18, which is 0, so therefore that is true also. Because, again, like we saw with the 3's, if I were to stick in a negative I squared, that would give us the exact same thing because, again, we've got even roots, and the even roots would cause the negatives to change into positives. Okay, so those 4 values would work. Again, our values were x equals 3. You could write positive and negative 3 that way. And it was a positive and negative I square root of 2. So those were our 4 values. So this is how you solve a quadratic with, or excuse me, a polynomial that is higher than a quadratic power of 2. Another polynomial equation here with exponents that are unlike what we're used to working with. So we have 4x to the negative 2 minus 9x to the negative 1 over 2. Remember that these negative exponents really do come down, so the x is underneath in the denominator. So we need to focus on changing this to a u. Okay, so if I just let u, just a basic u, equal x minus 1, that will change the equation to look like this, which is a lot better. Again, it's just a basic variable with an exponent of 1. But if I do that, I need to also substitute this. So what can I do to x to the negative 1 to change it to x to the negative 2? I raise it by 2. So I get u squared equals x to the negative 1 squared. So u squared has to be x to the negative 2. Okay, we're going to substitute that over here. So I get 4u squared minus 9u plus 2 equals 0. And then from here, it becomes a problem that we've done in chapter 5 where we just factored this out. Okay, since we have a 4 up front, we have to use the AC method, so I have to take 4 times 2, which is a positive 8. Think of factors of positive 8 that would add up to negative 9. And I have negative 8 and a negative 1, so I have to use the AC method to factor this out. Since I have 4 parts here, I can use factor by grouping, so I've done so. I can take out a 4u from the 4u squared minus 8u here, factor that out, and I get u minus 2. Because this starts with a negative, I have to pull out a negative 1, which changes this to u minus 2 again, because that negative 1 will change that positive to a negative. Factor by grouping again, and I get the two binomials 4u minus 1 times the quantity u minus 2. I have to set each of those equal to 0 and solve for my u's. So I have u equals 1/4 and u equals 2. Now remember, I have to go back and substitute these in to check my answers. So remember at the very beginning we let u equal x minus 1. So I asked to substitute my u value. U we said was 1/4 and u was 2, so we have to check these. Well, x to the negative 1 means 1 over x, and so I've substituted those in. I've changed 2 to a fraction of 2 over 1. So to get x in the numerator, you can just think of this as the reciprocal, or if we need to work it out, I would multiply both sides by x. I would get x over 4 equals 1. Multiply both sides by 4, and so x equals 4, which is again the reciprocal of 1/4 because x is in the denominator. Same thing can be said with this one. It's going to be x equals 1/2. But if we need to see that, we can multiply by x, because again I'm multiplying by the common denominator. I get 2x equals 1, divided both sides by 2, and so therefore x equals 1/2 and x equals 4. Okay, so those are our two values of x, and I have to go back and check my work. So these are the two x values that should work for this. Our original equation was this, so therefore it was x to the negative 2, so there should be two values in this equation. We need to check to see whether or not these two values right here, x equals 4 and x equals 1/2, work. Section 8.6 talks about parabolas and graphing quadratic equations. Now we did this a little bit in some of the previous chapters where we plotted points, both positive and negative, to find the shape of a quadratic or a parabola. Here we're going to talk about it a little bit further in detail. There are two different types of parabola. There's an opening one right here, which is a positive. Usually when you see this, your formula or your equation will say a positive x squared. Over here, this one is a negative x squared, so it's flipped underneath. Okay, the base or the point, the bottom part of it, or in this case, the top part of it, are called the vertices or the vertex. This one is a minimum because, again, it's the lowest point of the graph. And then over here, since it's flipped underneath, the vertex is actually a maximum. Okay. What's cool also about parabolas is that they have what's called a line of symmetry. You can draw a line through the center of a parabola and fold them over upon themselves, and they will be mirror images of each other. So that's what they call the line of symmetry. Every parabola will have one. Again, use your imagination. The pictures aren't completely perfect or accurate. Okay, parabolas do a couple of different things. They can either shift left or right, or they can shift up and down. Now our basic quadratic formula looks just like this-ish. Normally the basic is just y equals x squared. It starts at the center, the vertex is at 0, 0, and it goes up. They can shift left or right. This one is shifted right. This one is shifted left and down. Okay? One of the things that can change with a quadratic is the width of the parabola or the graph. It could either increase or decrease. Now a normal quadratic would look something like this, but they can get wider and they can also get narrower. So along with getting wider or narrower, it can also shift left or shift right, or it could shift up or shift down. So it really can take on any different combination of those three, and we're going to look at those in just a second. In section 8.5, towards the end of the section, it talks about vertex form. Now, back when we were talking about just linear equations, graphing just a straight line, there was a standard form, there was point slope form, there was graphing by using the X and Y intercepts. But again, the quicker method was to solve using, or to graph using, the slope intercept form. There is a quicker way to graph quadratic equations if it's in the correct form, vertex form. Vertex form looks like this. F of x equals a parentheses x minus h squared plus k. Notice that this looks exactly like when we were doing the completing the square. I wonder why. It's in the same section or same chapter, right? Chapter 8. So we will be using completing the square to get a quadratic equation into this format. Now, you can graph a quadratic equation just by plotting points. I kind of like this way because it tells you a lot of information. Okay, so let's look at what the parts stand for. The A that's out front here is what controls the width. Okay, how wide or how narrow the graph is going to be. If A is a fraction, it's going to be wide. So think opposite. So if it's a small number, it's going to be big. It's going to widen it a little bit. Whole numbers, if you have whole numbers in front here with your A, it's going to narrow it. Okay. Your H is going to move it left and right, so the number that is right next to the X inside the parentheses, right here, is going to move it left and right. Here you think opposite also. If it's a negative H, so if this is, let's say, minus 4, that means that you're really going to move it to the right 4. If this were a plus 4, you're really going to move it to the left 4. Okay, and then last but not least is the K, which moves it up and down. Now K is the only one that you have to think straight on. I hope you're thinking straight anyways. But if it's a positive K, it's moving up, and a negative K, you're moving down. So again, the only ones that you have to think kind of opposite on are your A and your H. And so let's look at how we would graph something like that in that format. Okay, so we have this equation here, f of x equals 1/2 x minus 5 quantity squared minus a 4. Okay, so let's look at this from the 1/2. The 1/2 tells us this is going to be a little bit wide, a little bit wider than normal. This is 8 and negative 5, so this is where we have to think opposite. Negative, we would normally think going left direction, but this is going to go to the right 5. And then here, this is a minus 4, so it's going to go down 4. And you always start in the center because that's where a basic parabola starts from or originates from, is from the 0, 0, as we saw in the previous pictures. So we start here and we go to the right 5. 1, 2, 3, 4. Okay, you need one more. 5. And then it's going to go down 4. 1, 2, 3, 4. Right here. This is where our vertex is going to be, right there. So what I like about this, since it's called vertex form, it tells you exactly where the vertex is at. So the vertex here is at 5, negative 4. There's no calculating it because it's already worked out for you. Okay, then we draw our parabola. Is this one going to be facing up? Is it going to go like this? Or is it going to go down like this? Okay, since this 1/2 is a positive, it's going to come up. So it's going to widen. So we would want to widen this just a tad. Okay, like that. And you'd be good to go for sketching a graph. Again, this is not perfect, but it is a good sketch because, again, it shows where the vertex is. And if I were to ask you for the line of symmetry, okay, what line would go directly through the vertex? And if we look right here, that's 5, right? What equation of a line would identify this right here, that dashed line? Well, since it's only going through the x-axis, this is a vertical line at x equals 5. So the x equals 5 would be the line of symmetry. Okay. Now, if I were to ask you for the x and y intercepts, X and Y intercepts right here and here. And again, don't pay attention to my graph because it's not accurate. I don't have graph paper on my board. We could do this two different ways. We could actually work this out so that it looks like a standard quadratic equation and use the quadratic formula on it. Or we could again get this back into standard quadratic form and then complete the square, which the complete the square is already there, right? So we actually could use completing the square for this. So let's go ahead and do that. Let's solve this by using the completing the square, and that would give us our x values or our x-intercepts. Okay, so I've taken my equation and I've stuck 0 in for f of x. Remember, to solve for x, we have to have that 0 there. I need to get 2x, so I need to get everything else away from x. And the first thing I need to move is this -4. So I'm going to add 4 to both sides. And I'm going to get 4 equals 1/2 x minus 5 squared. Then I need to move this half, so I'm going to multiply both sides by 2/1, and that's going to cancel here, giving me 8 equals x minus 5 squared. Need to get rid of the square, so I'm going to do the square root of 8, which equals x minus 5. So if I take the square root here and the square here, the x minus 5 is going to come down. And then to finish up, I have to add 5 to both sides. Okay, so I can write that as 5 plus or minus the square root of 8 equals x. So to find out my x values, I would actually need to work those two out. So x plus the square root of 8 and x equals 5 minus the square root of 8. So those are the two equations that we have to work out. So I worked them out and I got 7.83 and 2.17. Okay? So those would be our x-intercepts. And again, if I were to write these in an ordered pair, it would be 7.83, 0 and 2.17, 0. So again, ordered pair. Would we be able to find a y-intercept here? Well, a y-intercept happens when a graph crosses the y-axis. If it crosses the y-axis, that means x is at 0, right? So if x is 0, then this whole thing is going to be what? -5 squared, which is 25, right? So let's do that. 1/2 0 minus 5 squared equals 4. So this, we're trying to find out what our y is when x equals 0. I get 1/2 -5 squared minus 4. 1/2 of 25 minus 4. So half of 25 is 12.5 minus 4. So that would be 8.5. Okay, so that means that this graph will cross the y-axis at 8.5. If I were to write this in an ordered pair, I would have 0, 8.5. So, like I said, I kind of like the vertex form because it tells us a lot. We don't have to do a lot of work in order to get to certain values within our equation. So this is why I like the vertex form. Using the vertex form, we were able to find the vertex, which was at 5, -4. We were also able to find the 2 x-intercepts. We were also able to find the y-intercept. And so this is some of the points that are important. You'll need to find the vertex, the x-intercepts, and the y-intercepts. And the question you're asking is, what happens if the equation is not given to you in vertex form? We're going to go ahead and show you how to do that. Okay, in the last section, 8.5 and chapter 5, they'll want you to graph this quadratic equation. To put this into vertex form, we have to complete the square. So I'm going to go ahead and rewrite this like we're used to seeing back in section 8.1 and 8.2, completing the square. Okay, again, I'm going to move this to the right hand side, rewrite it as x squared plus 4x blank equals a negative 3. I need to take my b, which is my 4, divide it by 2, which is 2, but then I need to square it, which is 4, positive 4. So I'm going to add 4. But if I add 4 to the left-hand side, I have to add 4 to the right-hand side. I'm going to rewrite this as x plus 2 quantity squared. Negative 3 plus 4 is a positive 1. And so to change this into vertex form, all I have to do is move this one over here. So I get x plus 2 quantity squared minus 1, and that is going to be my new vertex form for this equation that we started up with right there. Okay, so they're the exact same thing. It just makes it a little bit easier for us to graph and to work with. Okay, so with that said, we're going to go ahead and find our x, our y-intercepts, our vertex, and we're going to graph it. To find our x-intercepts, we go ahead and set this equal to 0. X plus 2, quantity squared minus 1. Add 1 to both sides. X plus 2 squared, we would take the square root of both sides to get rid of that square there. So we would get a positive and a negative 1 equals x plus 2. Okay, to get x by itself, subtract 2 on both sides. So I'd have a minus 2 plus or minus 1. Because again, when I take the square root of 1, I have to have a positive and a negative value. So x is going to either equal a negative 2 plus 1 or a negative 2 minus 1. So in that case, we're going to get a negative 1 or a negative 3. So our x-intercepts are going to be at negative 1, 0 and negative 3, 0. So we can kind of already start seeing a picture, right? If we were to graph this. Negative 1, 0 is right here. Negative 3, 0 is right here. So those are our x-intercepts. Okay. Now since we already know our vertex form, we know that this equation is going to go where? It's going to go to the left 2 and down 1. So left 2, down 1. That looks about right. So here's our vertex. It's going to come up here and here. And it's going to get a little bit bigger here. But let's find out where that y-intercept is. We need to find out where that y-intercept goes so that we can kind of figure out the fuller shape of this. In order to find our y-intercept, we have to solve for y, which is the same thing as f of x. I have to substitute 0 in for x and work this out. Okay, so 0 plus 2 is just 2. 2 squared minus 1. And so this is going to be 4 minus 1, which is 3. So our y-intercept is going to be at 0, 3. Which it looked like it over here, right? 0, 3. We can kind of see that, right? Okay. And that's how we would graph it. Again, my lines are not spaced out correctly, so it doesn't look perfect, but again, my pictures never are. Just use your imagination. Okay, let's do another one. Okay, here's another example of a quadratic that needs to be graphed. We need to find the x-intercepts, the y-intercept, and the vertex. So I'm going to go ahead and write this in our with a 0 at the end so that we can complete the square. Actually, I'm going to write the 0 over here. Okay. Going to move the 15 to the other side by adding it to the other side. Okay, notice how I did not multiply through with a negative here because I have to make sure that I keep that negative out front because it's important now because this signifies that we have a parabola that is going to open downward, so it's kind of important. Okay, so I still need a positive one here, though. I'm going to factor out a negative from these two here. Okay, so this becomes a positive x squared and negative x and 15 on the right-hand side. Okay, so I do the same thing. I take my b, my negative 8, I divide it by 2, and I get a negative 4, and I square that, and I get a positive 16. And I put 16 here in my new spot. Okay, but wait a second, I got to add 16 to the other side. But really, this is not acting like a 16. This is a negative 16, because remember that negative is going to distribute through, so this is really not a positive 16, it's a negative 16. So I can't add 16 to the other side, but I need to subtract 16 on the other side. Okay, rewrite this as a negative 1 parentheses x minus 4 quantity squared equals a negative 1, because 15 minus 16 is 1. Okay, bring that negative 1 over, so I have a negative x minus 4 quantity squared plus 1 equals 0. And this is now my new vertex form of my equation, a negative x minus 4 quantity squared plus 1. Okay, so now that we have that down, we need to solve for our x-intercepts, our y-intercept, and our vertex. Okay, this is our vertex form of the equation that we start off with. Right away, I can go ahead and graph the vertex. So this is telling me that I need to go to the right 4 and up 1. So over here, I'm going to go to the right 4 and up 1 right there. And that's going to be a vertex. Okay, we know it's going to open down, so it's going to come down like this. So we need to find our x-intercepts. Okay, which means that I need to let my f of x equals 0, and I need to solve for x. I do that by subtracting 1 on both sides, so I get a negative 1 equals a negative quantity x minus 4 squared. Divide by negative 1 to get those negatives to cancel out. So I get a positive 1 equals x minus 4 quantity squared. Need to get rid of this square, so I need to take the square root of both sides. So I get a positive and a negative 1 equals x minus 4. To get x by itself, I need to add 4 to both sides. So I have 4 plus or minus 1, which is going to give me my x. So that means that x is 4 plus 1 and 4 minus 1. So we get 5 and 3. Okay, so we come over here. Well, 3 is here, 5 is here. Don't forget we need to put these in ordered pair. So this would be 5, 0 and 3, 0. Okay, so 5 and 3 are right here. It's going to open down. Okay, so far so good. We need to find our y-intercept. Our vertex is right here at 4, 1. And then our x-intercept at 5, 0, and our x-intercept at 3, 0. We just got to figure out the y. It's going to be down here a ways, it looks like. Okay, so let's go ahead and work that out. So we want to know what our y value is when our x value is 0. Okay, so we need to work this out. So we get a negative 4 quantity squared plus 1. Negative still up front. So negative 4 squared is 16, but the negative out front was still there. So we get a negative 16 plus 1, which is a negative 15. So again, it looked like it was going to go down quite a ways. So we would actually have to go all the way down to negative 15 and graph it. And that would come down like something like this. Okay. That's how we would work it out. So again, get your equation into vertex form. Use your vertex form to find your vertex. Then use your vertex form to find your x-intercepts, which we did here. Graph your x-intercepts. And then use your vertex form to find your y-intercept. So those are the 3 things they're going to ask for. Vertex, x-intercepts, y-intercepts, and then a graph. I guess that's 4 things. You guys knew what I meant. Anyways, good luck.